Hello, assalamu alaikum everyone. Welcome to my YouTube channel Economics Study with Farhana. So basically today I'm gonna tell you about the second part of time series data analysis. In the first part I have discussed about how you will go to step by step to calculate time series. So first of all you need to declare the data set as time series, then you need to conduct your unit root test. After that you need to find out your optimum lag. So these three procedure I have shown in my previous video. I will give that video link in the description box or it will be pop up at the top. You have to follow that video first, then you need to follow this video. So after selecting the optimum lag, you need to conduct either Johansen cointegration test or bound test for ARDL. So the cointegration test is basically we conduct to find out the long run relationship among variable. If all variables are stationary at a same level, that means if all variables are stationary at first difference, or if all variables are stationary at level, then we need to conduct Johansen cointegration test. But what if some variables are stationary at first difference and some variable are stationary at level? So in that case you need to conduct bound test from ARDL. So first of all I will show you the Johansen cointegration test. So for conducting the Johansen cointegration test you need to go to statistics, then multivariate time series, then cointegrating rank of vacuum. You need to click on that. You have to provide your dependent variable first and then the independent variables. After that you need to select your maximum lag which you have got from your optimum lag selection. We have got the optimum lag 4, so we need to select 4. After that you need to go to the reporting option, then you need to select here report maximum eigenvalue statistics to get the eigenvalue result also, and then you can compare the result. So after that you need to click OK. After conducting the Johansen cointegration test you will get the result like this. So the decision criteria for Johansen cointegration test is if trace statistics value is greater than 5% critical value, then we reject the null hypothesis. Here null hypothesis is there is existence of cointegration and the alternative hypothesis is there is no cointegration. If trace statistics is greater than 5% critical value, then we can reject the null hypothesis. That means there is no cointegration. Well, here you can see in rank 0 the trace statistics is 29.8440 and the 5% critical value is 29.68. That means the trace statistics is greater than 5% critical value in rank 0. So in that case we can reject the null hypothesis. So here we can see that the trace statistics is less than 5% critical value. So now we cannot reject the null hypothesis. That means there is cointegration and there is on cointegration as rank is on. So we need not go to the others as we have found that at rank on there is cointegration. That means in this study there is on cointegration. The trace statistics is less than 5% critical value. That means we can tell that our variables are cointegrated among each other and there is long run relationship and there is on cointegration. That means in rank on the trace statistics is less than 5% critical value. Now how will be the result if there is no cointegration? So the result would be like this. That means if there is no cointegration, then in that case the result would be like this. In rank 0 the trace statistics is less than 5% critical value. That means as in rank 0 there is trace statistics is less than 5% critical value, we cannot reject the null hypothesis. That means there is existence of zero cointegration. It indicates the variables are not cointegrated to each other and there is no long run relationship. Now if we look at the maximum statistics, we can again saw that in rank 0 the maximum statistics value is greater than 5% critical value. That means we can reject the null hypothesis. After that, if we look at rank on, then we can see that the maximum statistics value is less than 5% critical value. That means in that case we cannot reject the null and we can say that there is on cointegration. So if we look at the trace statistics, we can found that there is on cointegration, and if we look at the maximum statistics, we can again say that there is on cointegration.